Hello, ladies and gentlemen. Let's solve some log equations. We're going to use this exponential growth model, PE to the RT, for these problems, and then we're going to use what we've learned about solving logarithms to add one extra kind of step to it. So we've done a lot of the first part here. It says the world's population was approximately 6.1 billion and growing at a rate of 1.2%. Create a model to represent the world's population. So I'll say like P of T, P for population, and T for time. The principal here is 6.1. What we're starting with is 6.1. We'll just say it's in billions, so we know our answer will be in billions. And then it's e to the 0.012. That's the growth rate, and then t for time. Okay, so if I just said estimate in 2020, you would say 6.1 e to the 0.012. And then since it's from 2000 to 2020, that's 20 years. So we'll just use a calculator here. We've done a bunch of these. We're going to say 6.1 e to the 0.012 times 20. Okay, and that's 7.75 billion. Okay, fine. That's about right. 5 years ago, we're floating around 8 billion now. Cool. Now it says algebraically solve to determine when the population will reach 10 billion. Now that's a different question. So I'm not giving you a time, I'm giving you the population. So what we're going to do is say P of T, that's the population, is 10 billion, and I'm going to set it equal, and we're going to solve for T. And the whole reason that we have logarithms is to get these variables out of the exponent. So just like we've been doing, the first thing we need to do is isolate the logarithm, or the exponential in this problem. And now we've got this decimal, 10 divided by 6.1. Now, I don't want to round anything. I'm going to leave that. I'm going to keep all those decimals in my calculator, but when I write my steps, I'll just say 1.64 equals e to the 0.012t. Now that you get here, you can kind of think of this as two different ways of approaching the problem. The first one is, let's just pretend that we're rewriting this exponential as a logarithm. And remember, log base e, we use the words natural log, but if it helps you kind of see it, it's like, okay, there's an e here. E to the power of 0.012t, there's like an e there, is 1.64, okay? If you can get to there by rewriting the log, we're going to be able to solve this pretty quickly. The other way you can approach these problems is when you get to this part, you can also say like, well, what if I took the log of both sides? The natural log of the left side, 1.64, and the natural log of a base e exponent is just going to give you this guy. And based on some rules of logarithms that we haven't really talked about, those cancel each other out and you just get the exponent. But either way, once you get here, now it's a one-step equation. To get t by itself, you're going to divide by 0.012. But what I want to make sure you do is don't round anything. We're going to say the natural log of that number, and then you close your parentheses, and then we're going to divide by 0.012. And we get 41.19. We'll say 41.2. And what is 41.2? That's years since 2020. And I can check my answer by saying, take the model that we have, and instead of 20 years, I'll say 41 point, I'll keep the 19 there. In 41 years, what I'm saying is, I believe the population will now be 10 billion. So when I plug it in, what do I get? 9.99998. Great. We did well, we rounded, okay? If I keep all the decimals, I'll show you. Go back up here. This is why I don't want you to round. I want you to keep all the decimals. If you keep all the decimals and you check it, it comes up to 9.9999. That's 10. Okay, so we did it. Okay, it would be the year 2041. The year 2041. The population will reach 10 billion. Okay, so we're solving now for the year. Instead of plugging it in and getting the value of the account or whatever, we're finding when it'll happen. Let's try another one. 3,500 is the amount we're starting with. We're using the continuous model, and it's 0.06t. So there's our model. And if I want to find after 5 years, I'd say 3,500 e to the 0.06 times, it was 5 years, right? Just make sure, times 5. And after 5 years, my account will be 4724.51. 4724.51. Okay? So I know how much will be in the account. We started with 30. 3,500. Now we're at 4,700. Great, we made a little bit of money. But now I want to know, hey, when will this 3,500 bucks be worth 20,000? So we'll say 20,000 equals 3,500 e to the 0.06t. Now, we play the same game. You got to first isolate the exponent. So divide both sides by 3,500. So 20,000 divided by 3,500. And I'll write it as 5.71. 5.71 equals e to the 0.06t. And now we need to, again, rewrite this as a logarithm. And since it's base e, we're going to say natural log. And it's like e to the power of 0.06, that's on the other side, equals 5.71. And the last thing to do to solve this equation is you're going to divide both sides by 0.06. We just need to have the calculator do the work for us. So I'm taking the natural log of that gross number, and then I'm going to divide by 0.06, and I get 29.05. T equals 29.05. So in 29.05, about 29 years, it'll be worth $20,000. In 29 years, the account will be worth $20,000. It's always good with a word problem. You want to use a sentence to answer your question. And I can't write very well, so I'll use my keyboard. Now, again, it's a good idea to check your answer. 3,500 e to the 0.06 times, and I'll type in 29.05, and it should be really close to 20,000. And it is, right there, 61 cents extra. Sweet. Okay. Let's do a couple more. This one says depreciate. So remember, depreciate means it's losing value. So we're going to start with $18,000 e, and now it's negative 0.09t. There's our model. And what will be worth in 10 years? Okay, 18,000 e negative 0.09 times 10 years is 7318.25. 7318.25. Okay, great. We've done a bunch of that. Now what we're adding is, can you tell me when it will be worth a certain value? Half of its purchase price. So that would be worth 9,000 if it were originally 18. So 9,000 equals 18 e to the negative 0.09t. So the first thing you do is you divide by 18,000. And this is a good way of kind of processing, like, oh, you want to know when it's half, just set that equal to 0.5, negative 0.09t. And now the next step is to rewrite it as a logarithm. And since it's base e, we're going to use natural log, negative 0.09t. Now remember, it's like e is your base, so e to some exponent is 0.5. That's how you kind of go through that. We just got to divide both sides by negative 0.09, and then it's all calculator work. So the natural log of 0.5 divided by negative 0.09, 7.7. 7.7 years. Okay, and if you look at up here, in 10 years it was worth less than 9,000. So I should have expected it to be less than 10 years because I know in 10 years it's going to be worth less than that. But if I type my answer in now, 18,000 e negative 0.09 times 7.7 years. In 7.7 years, it will be worth 9,000 bucks. Again, we're creating a little bit of error every time we round. That's why I want you to round as little as possible when you're working through these problems. Let the calculator carry the decimals if you can. One more. Oh, let's write the answer. So, like I said, it's always good to write your answer in a sentence. Okay, the boat will be worth half of its value in 7.7 years. And just make it a little smaller. There you go. Okay. Got it. All right, one more. What's the last one here? Okay, suppose you inherit $150,000. So big money, 150,000 e to the 0.07t. That's easy. Now, if I want to find 20, 150,000. So you put this money aside, you leave it alone, you let it get big. 20 years later, how much money you got? Woo, 608,279. 608,279.9. Well, you know what? We'll just round it up. 80. Okay, 20 years, 600K. Sweet. Now, when will be a millionaire? So we'll say a million equals 150,000 e to the 0.07t. So the first thing I need to do zeros. 6 zeros good. Divided by 150. These are big numbers. All right, so 6.6 repeating. 6.6 equals e to the 0.07t. Now we need to take the natural log of both sides, or think about it as rewriting it as a natural log. And now I'm going to divide to get t by itself. You divide by 0.07. So we're taking the natural log of this number divided by 0.07. 27.1. T equals 27.1 years. So in 20 years, it was worth 608K. If you wait 7 more years, you're at $1 million now. So 150,000 e to the 0.07 times 27.1. So this should be real close to $1 million. Oh, it's 7%. I typed a 4. 7%. So 7% interest for 27 years turns your 150K into right about $1 million. Okay, and if I keep the extra decimals, like I said, it'll be right there. Let's just try it to be sure. Okay, so 27.1. Keep all of them up here. This whole number. Boom. There it is, $1 million. Let's go. Okay, so we're rounding, and these little decimal errors can add up. So you want to carry all the decimals that you can when you're working through the problems. That's it for exponential growth and using logarithms to solve. So make sure you hit that like and subscribe.